Hey guys, welcome back to week 3 here. Talking about chapter 6, measuring distances. I'm going to pull up the book itself. Let me get the table of contents out here. Let's see, theories and methods. I want chapter 6. Let's just click on that. Distance and measurements. So distance measurements, chapter 6. This is out of the Pearson book. So again, there's different methods for measuring distances. Traditional ground surveys based on angle reads, at least one line must be measured to supply the angles in locating points. In plane surveying, the distance between 2 points means horizontal distance. If the points are at different elevations, the distance is the horizontal length between the vertical lines at that point. So in our world, we there are different methods of linear measure. There is pacing, which we use in like topographic surveys to just kind of establish like cross sections. We don't use odometer readings. We don't use optical rangefinders. We the stadia tectometry or stadia is kind of an outdated method. We don't really use subtense bars. We do use taping, and we use the electronic distance measurements or EDM. We use the satellite systems, of course, and so those out of those three, pacing, EDM, and GNSS are the three most rapid or the most available for a land surveyor to use nowadays. So let's get into kind of just the method of pacing, right? So pacing is distances obtained by pacing are sufficiently accurate for many purposes. So again, it's used for just detect kind of just blunder stuff. So again, GME 161, we did this slab one, established your pace. So that way you can kind of figure out where exactly, just to get in a rough idea of the area that you're working with, right? I'm going to skip over a couple of these because we don't need to talk about a few of these. So taping, right? With taping, we want to use like one of those 100-foot tapes. And so again, there's kind of like 6 steps in performing taping. There's lining in, so getting your point A to point B. When you're pulling, you're applying the correct amount of temperature or tension, which is 20 pounds. Plumbing, making sure you're horizontal and right over the points, and then marking tape lengths, which again, if your distance is over 100 feet, you got to go more. You got to mark, where you're breaking the tape and continuing on from there. And again, reading the tape and then recording your distances. That is the steps to taping. And again, what I do have actually, and what I'll be posting is I had Pearson has these videos, and I think they have it. I think they show it here. I think I have them available, and I'm gonna try to post those for you guys so you guys can watch those, and they give you a bit more technical background on the taping and as well as other methods of the surveying world. So this figure 6.1 that we have the steel tape itself. We have the range poles, kind of the guidance systems that you can place behind A and B, your points that you're measuring to. You have these tape reference markers, these little pins that you set in the ground as you're breaking the tape. And you have your plumb ups in order to be right over the point. And again, surveyors and engineer tapes are more made out of this 1/4 inch to 3/4 inch wide steel, and they weigh to 2 to 3 pounds per 100 feet. Um, those graduated in feet are most commonly 100 feet in length. While they're available in 2 to 3 and 500 feet, they are marked with in feet, tenths, and hundreds. Metric tape have standard lengths of 30, 60, 100, and 150 meters. All can be wound and reeled. So one thing you need to understand about steel tapes is with temperature, they do expand and contract. And those are one of the corrections that we would always have to make sure you to apply to when you're working with pulling tape. So again, taking care of equipment, considering the cross-sectional area of average surveyor steel tape and provisional stress, a pull of 100 pounds will do no damage, but if the tape is kinked, a pull of less than 1 pound can break it. So you always have to make sure that you don't have any kinks or loops when you're trying to apply these things. If a tape gets wet, wipe it first with a dry cloth, then we need to oil it down tape should be kept in either on a reel or thrown in circular loops, but not handled both ways. So one or the other. Each tape should have an individual number or tag to identify it. Broken tapes can be mended by riveting it or applying a sleeve device, but a mended tape should not be used on important work. And then range pulls are made with metal shoe and point in line with the section above. This alignment may be lost if the pull is used improperly. So, oh, here's one of those videos. I won't play it here. This is my video. It's just a quick overview on everything, just methods of applying this stuff. And then I will show, and then those videos I will try to post on YouTube as well for you guys to work with. So there's the steps for the pulling tape. We have lining in. So again, using those range pulls between A and B on either end, so you guys can have your guide to get there. You applying tension. So the rear tape person holding the 100 foot end of the tape, right? And then you have the forward person going holding 0 at the other side. And again, your specific tension is somewhere between 10 to 25 pounds, and you're maintaining a steady pull as you're going through the whole thing. Then, as well as plumbing. So, weed, brush, obstacles, and surface irregularities may make it undesirable to lay a tape on the ground. In those cases, the tape is held above ground in horizontal position, placing a pump blub string over the proper tape graduation and securing it with one thumb. Mark each end on point on the tape. The rear person continues to hold a plumb bob over the fixed point while the forward tape person marks the length. In a measuring distance shorter than a full tape length, the forward person moves the plumb bob string to a point on the tape over the ground mark. And then, as well as again, when you're breaking that tape or breaking the measurement because you're not going the full 100, you're marking tape lengths. So again, when tape has been lined and properly tension has been applied, the rear person is over the point. Stick is called out. The forward tape person then places a pin exactly opposite of the 0 mark of the tape as a can call stuck. The mark point is checked by repeating the measurement until certainty is correct location is assumed. All right. So after checking the measurement, the forward person signals that the tape that the point is okay. The rear person pulls the rear pin and they move ahead. The forward person drags the tape pacing roughly 100 feet and stops. The rear tape person calls tape to notify the forward person that they have gone 100 feet just before the 100 feet and reaches the pin and has been set. The process of measuring 100-foot lengths is repeated until a partial tape length is needed at the end of the line. So that is kind of the method or the marking tape lengths. So reading the tape, there are two types of common styles of graduations in 100-foot surveyor's tape. It is necessary to identify the type being used before starting work to avoid making 1-foot mistakes repeatedly. So the common type of tape has a total graduation of 101 feet. It is marked from 0 to 100 by full feet in one direction. So an example here, it is just, you'll see you have foot 1, you have foot 2, and then so on and so on, and then you have foot 87. So again, that is how the normal are shown. So again, for mark 0, additional and then it has an additional foot preceding the 0 mark from 0 to 1 in tenths, or in tenths and hundredths in the other direction. In measuring the last partial tape length of a line with this kind of tape, a full graduation is held by the rear tape person at the last pin set. So like the 87 foot mark in this figure, the actual foot mark held is the one that causes the graduations to on the extra foot between 0 and the tape to straddle the closing point. The forward tape person reads the additional length of 0.68 feet beyond the 0 mark. In the case illustrated, ensuring correct reading, the rear person calls 87. The forward person repeats and adds the partial foot reading to calling 87.68. Since the foot has been added, this type of tape is known as an add tape, right? So if it was the other way around, it would be called the cut tape. And so let's talk about that real quick. The other kind of tape found in practice has a total graduation of 100 feet. The mark is from 0 to 100 with a full foot increments in the first foot at each end from 0 to 1, and 99 to 100 is graduated in tenths or in tenths and hundreds. This kind of tape, the last partial tape is measured by holding a full foot graduation at the last chaining pin set at the graduation section of the tape between 0 and mark and 1 foot mark straddles the closing point, again indicating at 6.2b where the 88 mark is being held, and the last chaining pin and the tacking mark at the end of it at the end of the line, as opposed to 0.32 from the 0 end of the tape. The partial length is then 88, and then you have 0.32 subtracted, right? And so that would get 87.68 again. The quantity of 3.28 is said to be cut off. Hence, this type of tape is called the cut tape. To ensure subtraction of a foot, the number of full graduations used, the following procedure are recommended. Rear tape calls 88. Forward person says cut 0.32. Rear tape person answers 87.68. Forward person confirms the subtraction and replies check when satisfaction is correct. So these are the two. The 101 is much easier to keep it in line with yourself out in the field, because all you're doing is just adding that next rather than trying to remember to subtract. So there's also breaking tape when you are on steeper slopes, and that is the procedure called breaking tape. Breaking tape. Let's see if I can find a figure for you. So, oh, here we go. 6'4", right? So again, let's say, because plumbing above your head or anything like that is pretty much impossible. And let me see if I can I zoom into this guy, or can I just pull that figure? I can pull that figure. So right here, they're breaking tape, right? That's definitely not 100 feet. That looks more like 20 feet. So they broke tape at like 20 feet, and then right here, I'm not sure if you can tell, there's a plumb bob. While this guy has he's pulling tension here, and he has his plumb bob, and he's reading that plumb bob at one of the foot graduation markers, and he's going to put a reference marker there, while the rear tape person is holding it at wherever point A is here, or whatever starting point that is, as they're marking away that way. Right. So again, in this other example, they're breaking tape. They're going down the hill, and they broke tape at 30 feet here. Then they broke down another. So that's 100-foot mark on the tape, and then 70-foot markers at the tape, and that's 30 feet. Then from there to there, they went 70 feet, and then they went 25. So that's another 45. And then here is 25 to 0, and that's a total of 100 feet as they were breaking tape. So taping downhill is preferred, measuring uphill for two reasons. First, in taping downhill, the rear point is held steady on a fixed object while the end is plumb, and taping uphill, the forward point must be set while the other end is wavering somewhat. Second, if breaking tape is necessary, the head person can move conveniently, used as hand level is proceeded downhill a distance which renders the horizontal tape when held comfortably at chest height. All right, so slope measurements. So slope measurements are considered to be always trying to reduce those to horizontal, okay? So when we have a horizontal or a slope distance, so L being your slope distance here, you have your slope distance, you have a zenith, and you have an H, right? And it's measuring those distances rather than break tape every few feet. It may be desirable to tape along the slope, compute the horizontal component, and that requires measurement either side of the altitude angle. So in taping, it's not very, it's a little harder. It takes a little bit more time. If we're doing EDM stuff, that is a much better way. Like when we're again doing using total stations, this we can definitely figure out our horizontal distance by recording the slope, recording our vertical angle, and then reducing that horizontal distance. So let's see here. So here is our formula 6.1a to get these to slope right? And figure out if the altitude angle is determined, the horizontal distance between point A can be computed from the following. H is equal to the slope distance times the cosine of our angle, and that way, where H is a horizontal distance between points, L is the slope separating the altitude angle from horizontal or zenith, I guess. Use altitude angle usually obtained from the Albany hand level or clinometer. And again, we don't really use this method. It's kind of an outdated method, but this is an example of what you would want to do if you were doing slope distances. But again, we do this with our total stations, and we can get those figured out. And so that is just another example there. Let's see here. Oh, and then we have sources in error taping. And these are in this video too, I will try to post. But the three fundamentals of sourcing or errors is instrumental errors. A tape may differ in actual length from its nominal graduated length because of a defect in the manufacturer repair. We have natural errors. The horizontal distance between end graduations of a tape varies because of the effects of temperature, wind, and weight itself. And personal errors, the tape person setting pins, reading tape, or manipulating the equipment, right? Those are the three type of errors: instrumental, natural, and personal errors. So with the precision of the EDMs in today's total stations, taping is seldom used. Like I said before, for precise work has been regulated to use in areas where low accuracy is required. However, when a tape is used, these sources of errors can be understood and avoided. For example, an offset measurement or time measurement for a station taken with a tape should not be subjugated to personal errors. The effect of a personal systematic errors sources in taping are discussed in subsections that follow. Due to the precision and the accuracy of EDM instruments, precise taping, which requires these corrections, is seldom performed today. Appendix A contains the example of tape corrections, but again, I'm going to post that in the video, so we won't really go over those things right now. Yeah, these all be posted in the video of from Pearson, and so you guys can just get a quicker explanation from them. The one thing that sag is another type of portion. So again, if you are pulling correctly, and again, that is we don't have what we call a supported, right? It's only at the ends. So we have the rear and the forward person pulling. The tape itself in the middle will sag, right? And so we have to have this, what we call a sag correction. And that again will be in the other video that I will try to be posting for you guys. Tape not horizontal and tape offline. So corrections for errors caused by tape being inclined and vertical plane are computed in the same manner as corrections for errors resulting being in offline and horizontal plane. Correct length to be determined by the equation 6.2 back there, where the vertical plane D is the difference in elevation between the tape ends, and in horizontal plane D is the amount of where one tape is offline. In either case, L is the length of the tape involved in the measurement. Errors caused by the tape not being horizontal or systematic always make recorded lengths longer than true lengths. They're reduced by using a hand level to keep elevations of the tape ends equal, or by running differential levels over a tape points. All right. So again, we're just going over the theory over these things. Yeah, are we going to be working a lot with steel hand pulling? Not really, or taping, should I say? It's just one of those things that can if you ever need to do these things kind of for, I would say, setting references or for, I would say PLSS corners. This is a lot where you would be running into taping is, for setting references to a bearing tree, those type of issues. This is where you would be running into taping. So the other source in taping is improper plumbing. Practice and steady nerves are necessary to hold a plumb bob long enough to mark a point. The plumb bob will sway even in calm weather on very gradual slopes or on smooth surfaces such as pavements. Inexperienced tape persons obtain better results by laying the tape on the ground instead of plumbing. Experienced tape persons plumb most measurements. So again, this is just by practice, right? Practice makes perfect type of work. Faulty markers. Chaining pins should be set at perpendicular to the tape length, but inclined 45 degrees to the ground. This position permits plumbing to the point where the pin enters the ground without interference on the loop from the loop. Brush, stones, and grass or weeds deflect a chaining pin may increase the error of incorrect marking. Error from these sources tend to be random and kept small by carefully locating a pin, then checking it. Incorrect reading or interpolation. Interpolation, yeah. The process of reading to the hundreds on tapes graduated only to tenths or to thousands on tapes graduated to hundreds is called interpolation. Errors from the source are random over the length of the line. They may be reduced by reading and employing a magnifying glass or a small scale to determine the last figure. So in summary of those effects, an error of 100th of a foot is significant in many surveying instruments. Lists the 9 types of taping errors classified as instrumental, natural, personal, systematic, or random, and gives a departure from a nominal that precedes an error of 100 foot and a 100-foot length. So again, summary of errors, you have length temperature, which is I, systematic, and that is 100th over 100-foot length tape. Temperature, 15 degrees. Pull, 15 pounds. Sag is 0.6 at the center. Alignment is 1.4. Tape not level is 1.4. Plumbing, 100th. Marking, 100th. Interpolation, 100th. All right, so that is the end of taping. We will get into electronic distance on the next video. So I will post this, so we be on the lookout for the next post of EDMs. All right, thanks everyone.